Good morning. So today's lesson is all about trace tables. So it's how we can step through and understand an algorithm. So by the end of today, we want to make sure we know what a variable is, and we can step through an algorithm to see how the contents of a variable changes. And we're going to use trace tables for that. So these often come up in your paper 1 exams, and they're a really nice way to pick up some easy marks. Why do you use trace tables? Well, they're the only way really to help us identify the hardest of the 3 types of error. So we said there's 3 types of errors. The syntax error is the easiest one to find and fix because the program won't run at all until you fix it. And they're quite easy to fix because you get the error message that tells you the line of the number where the error is. It might not be on that line, but it will definitely be on that line or the line above or the line of code above. And then you've got your runtime errors, which try and run and then crash when it tries to do something impossible. But trace tables are helpful for logic errors, which means your code does what your code has told it to do, but we've told it to do the wrong thing. And the only way we can find and fix that is by stepping through and working out what we've told our code to do. And we also use them to work out what an algorithm actually does. So if we have an example algorithm, our job is to first of all identify, that's why we do the keywords challenges with the compete.code.uk things each week. So you can look at this and say, oh, this is a variable and it's a list. This is a variable, this is a variable, this is a variable. This is an expression. This is an expression, this is an expression. And we're basically trying to work out what all of the variables and expressions are. So let's step through. I always find it helpful to pop a finger on your piece of paper or highlight something if you're doing it digitally. So we first of all say, right, my list, thankfully it's not on a trace table, we don't need to write it down. Total, well, we initialize variables at the start. You don't have to do it in Python, but you get marks for it in Excel and it's considered good practice. So at the start of the program, we set an initial value. Total is set to 0. Fab. Position is initialized. We set the value to 0. And then we're changing the value of position. So you could say, well, what's the point of initializing it first? And Edexcel would say, well, it tells us that this is going to be an integer variable. I know and you know that Python says that this is unnecessary, but we get marks for it, and it's good practice to initialize your variables, your global variables, once at the start. Okay, so then we're changing the value of position, and we're changing it to 4. Why? Well, we work out the length of my list, 1, 2, 3, 4, 5, len for length. Len is a function, a built-in function. It has one parameter, the thing that we're measuring the length of. The return value from length is the number of items in the list. And then we take 1 away. So 5 minus 1 is 4. Notice we don't cross that out and put it in the same box. The variable changes, so we put it underneath. Right, now we have an expression. An expression is a combination of variables, numbers, values, and operators, and even function calls can go in expressions too. So whilst the position is greater than or equal to 0, well, it is. Look, position is greater than or equal to 0. So therefore, these lines are going to repeat. If it was me in an exam, my thumb would be splatted on the piece of paper just next to this line at the moment, because that's what we're about to do. So what we're about to do next is print, that means output, the thing in your list at position, position. So position is 4. So we want to find the 5th value, 0, 1, 2, 3, 4. So the item at position, the item at index 4 is 50. I hope that we should see a 50 in here. Yeah, there we go. So it's appeared on the next line because we're doing the next thing. Let's see, total is going to be what total was, 0, plus the value that we've just displayed, my list at position. So I don't like that. I would have put 50 in first and then say, I suppose it is, isn't it? It's 0 plus 50. That's fine. And then we update the position. So position equals position minus 1. That decreases down there. Okay. Then we go back round the loop. So the next time round the while loop, we want to display the value at position. So the value at position is now, okay, what's position? Position is 3, 40. So we display that one. Total is going to be set to what total was, plus that value of 40, so 50 plus 40 is 90, that's why we've got a 90 here, and we decrease position. So can you see the value of the trace table? We're stepping through line by line, writing in how the values change. And then we keep going through for each value in the list. And then outside of the loop, we then have to print the total on a new line in our trace table, 150. So I just want you to have some practice of that, please. So we are on CT15. You have, is that the same one? 10, 20, 30, 40, 50. It looks suspiciously similar. So even if you don't get this one, you've got this in the PowerPoint that you can access. But first of all, you have to identify all of the variables, and then you have to work out how the variables change as you go through each line. Let's make a little start. First of all, let's write down all of the variables. We have a variable called total, which is set to 0. Then we have a variable called position, which is set to 0. Don't like the auto capitalization. Shift and F3 toggles capitalization. And then after we've set position to 0, it immediately gets set to length of my list minus 1. Well, my list contains 1, 2, 3, 4, 5 values. 5 minus 1 is 4. Then it says while position is greater than or equal to 0. Well, 4 is greater than or equal to 0. So it should print. Well, I haven't got a column yet for printing or the output. Let's put that in. Print my list at position. Well, position is 4. So that's treated as the indexing expression, the value within the list that we're looking at. So my list at position 4. 0, 1, 2, 3, 4 is 50. Notice we write it on the line we're currently up to. Then next line, total. Well, I haven't got a thing in. Oh, I have got a thing for total. I don't really like going backwards in a trace table. So if it was me, I'd probably move on to the next one and say the total is going to be what the total was plus that value. So I'm going to say 50. Position equals position minus 1. So position is going to get decremented to 3. Right, what happens next? Back round the while loop. We display my list at position something or other. At position 3, 0, 1, 2, 3. That's 40. Then we work out the new total value. So the total is what total was. So it was 50. We want to add on 40 because that's the value at the current position. 50 plus 40 is 90. And we change the position. We decrease the position to 2. And you should be able to work out the rest from here. If you're really struggling with these, you can step through by pressing Control and full stop, and it will tell you the values of the variables. But I really don't want you to do this unless you're checking what you're doing, because the whole point is you should be able to do this on paper in a paper 1 exam where you don't have access to a computer. If you want to check, you can do Control and full stop, or if you're in Phony or Moo, then you have to, if it's in Moo, you have to enable debugging, press the debug menu and then step through. Okay, so let's have a look at activity 2. It's the same kind of idea. The idea with trace tables is you're guaranteed to get 0 marks if you leave it all blank, but you can pick up some easy marks. They're usually worth about 6 marks, 4 to 6 marks, if you can follow these steps. So here's an algorithm. Complete the trace table to show execution. Often you get given the variable or the expression names. So let's just work out right from the top. We don't have to write down what the list value contains. You might have to in an exam, but this doesn't ask us to. ABC is an integer variable, which is initialized to 999. Index is initialized to 0, so we know they're both integer variables. They store whole numbers. Length is then set to the length of my list. So that we have a function called len, a parameter called my list. So my list, this list of 1, 2, 3, 4, 5, 6, 7, 8, 9 values is passed to len. Len will count them all and return a value 9 because it's counted them all. So that return value gets stored inside length as 9. Right, while index is less than length, well, we look at our trace table. Index is less than length. 0 is less than 999, so lines 7, 8, and 9 are going to be run. Then it says if the value in the list at position index, what's index? 0. Thank you, trace table. So the item at position 0 is 88. Is that value 88 less than ABC? Well, ABC is 999. 88 is less than 999. So yes, this expression is true. So we run the next line. ABC then is assigned to the value of my list at index. Index is 0. We look at the first value, 88. Boom. All right, line 9. Index is what index was plus 1. Index was 0. 0 plus 1 is 1. We pop that value in there. Then we just keep going round. So this time, is the value in the list less than ABC? Yes, it is. So therefore, ABC is that value, 66. And we increase index by 1. So the first time round, you have to do it really carefully. After that, you get an idea of what happens, and it's much faster. Right, what's going to happen this time? We're now looking at index 2, 44. Is 44 less than 66? Yes, it is. So therefore, we plop it in, and we increase our index. The next one, 22. You get the idea. You need to finish off the trace table. Be careful when you break out of the loop. This print statement is a separate level of indentation, so you must move on to the next line. I got caught out by that in the mocks last time round. You change indentation, you move to a new paragraph of code, always move on to the next line. So hopefully once you've done this a few times, you can spot what's happening with the algorithm. And we said that's the second purpose of a trace table. The first is to spot any errors and to step through and see how variables change. And the second is to be able to work out what an algorithm does. So where did I get to? I've got up to index 4, 0, 1, 2, 3, 4. I'm now looking at 33. Is 33 less than 22? No, so I don't update ABC. But notice this is not indented as part of the if statement, so index still increases. That means I look at the next value. 99 is not less than 22, so I don't set ABC, I just increase the index. But 11 is less than 22, so I'm going to pop that in there. In fact, I'm going to do it down here, because I don't like going backwards in trace tables. And I still have to increase the index. But that is not less than 11, so I just increase the index. 55 is not less than 11, so I just increase the index. Now I'm saying, is index less than length? Well, length is 9, index is 9, so no, index is not less than length, they're the same. So I finish the while loop, break out of the while loop, and all we need to do now is display the results, which is ABC. ABC stores 11. Make sure you put it on a new line down here, because we're outside of the while loop, and that's it. So, very important question. State the purpose of this algorithm. What does it do? You put in your own words, please, what this algorithm does. It just scans through and finds the minimum value in a list. All right, so this time with activity 3, we've got an algorithm with a logic error in. So we complete the trace table with the errors that are here. Let's have a look. We've got a list with 6 zeros. Roll is set to 0 on line 4. For count in range 10, so this is an interesting one. Count will start at 0, and then we're going to do count 1, 2, 3, 4, 5, 6, 7, 8, 9. Remember, for something in range goes up to, but not including that value here. So let's see. Roll equals random.randint. Well, how on earth do we put random numbers in a trace table? Because we don't know what that's going to be. So that's a random number. That's silly. Does it tell us what the random numbers are going to be? Oh, it does. Yeah, here we go. Complete the trace table with rolls of 3, 5, and 6. So there we go. The first roll is 3. Then we print the roll. So output is going to be 3. Roll table roll is roll table roll plus 1. Well, okay. So roll table at position 3, 0, 1, 2, 3. is going to be what it was, 0 plus 1. Good. Notice you don't have to fill out all of the columns, you just put in the ones that are changing. And then let's go back round again. So the second roll, we get count is now 1. The next roll is going to be 5 from here. We display that value here. And it says roll table roll. So 0, 1, 2, 3, 4, 5 is going to be the value at that list, which is 0. At that list position, plus 1. All good so far. But then next time round the loop, we increase count. We get another roll, so 6. So roll is going to be 6. We display the 6 on here. And this time, this is where we're going to get a runtime error because of our logic error. We're saying roll table roll. Oh, we're trying to find the value in the list at position 6. It doesn't have a position 6. So I'd like you to discuss and to write down what the error is and how you could fix it, please. So please save the worksheet, make sure it's saved before you upload, and it gets uploaded to Half Term 9, Algorithms and Programming 9 for me, please.